How game theory can make AI more reliable. Researchers are drawing on ideas from game theory to improve large language models and make them more correct, efficient, and consistent. Imagine you had a friend who gave different answers to the same question, depending on how you asked it. What's the capital of Peru? Would get one answer, and is Lima the capital of Peru? Would get another. You'd probably be a little worried about your friend's mental faculties, and you'd almost certainly find it hard to trust any answer they gave. That's exactly what's happening with many large language models, LLMs, the ultra-powerful machine learning tools that power ChatGPT and other marvels of artificial intelligence. A generative question, which is open-ended, yields one answer, and a discriminative question, which involves having to choose between options, often yields a different one. There is a disconnect when the same question is phrased differently, said Athul Paul Jacob, a doctoral student at the Massachusetts Institute of Technology. To make a language model's answers more consistent and make the model more reliable overall, Jacob and his colleagues devised a game where the model's two modes are driven toward finding an answer they can agree on. Dubbed the consensus game, this simple procedure pits an LLM against itself, using the tools of game theory to improve the model's accuracy and internal consistency. Research exploring self-consistency within these models has been very limited, said Shea-Egan Omichifai, Chief Scientific Officer of the robotics company Field AI. This paper is one of the first that tackles this in a clever and systematic way by creating a game for the language model to play with itself. It's really exciting work, added Ahmad Bahrami, a research scientist at Google Research. For decades, he said, language models have generated responses to prompts in the same way. With their novel idea of bringing a game into this process, the MIT researchers have introduced a totally different paradigm, which can potentially lead to a flurry of new applications. Putting play to work. The new work, which uses games to improve AI, stands in contrast to past approaches, which measured an AI program's success via its mastery of games. In 1997, for example, IBM's Deep Blue computer beat chess grandmaster Garry Kasparov, a milestone for so-called thinking machines. 19 years later, a Google DeepMind program named AlphaGo won 4 out of 5 games against former Go champion Lee Sedol, revealing another arena in which humans no longer reign supreme. Machines have also surpassed humans in checkers, two-player poker, and other zero-sum games, in which the victory of one player invariably dooms the other. Posing a far greater challenge for AI researchers was the game of diplomacy, a favorite of politicians like John F. Kennedy and Henry Kissinger. Instead of just 2 opponents, the game features 7 players whose motives can be hard to read. To win, a player must negotiate, forging cooperative arrangements that anyone could breach at any time. Diplomacy is so complex that a group from Meta was pleased when, in 2022, its AI program Cicero developed human-level play over the course of 40 games. While it did not vanquish the world champion, Cicero did well enough to place in the top 10% against human participants. During the project, Jacob, a member of the Meta team, was struck by the fact that Cicero relied on a language model to generate its dialogue with other players. He sensed untapped potential. The team's goal, he said, was to build the best language model we could for the purposes of playing this game. But what if instead they focused on building the best game they could to improve the performance of large language models? Consensual interactions. In 2023, Jacob began to pursue that question at MIT, working with Yikang Shen, Gabrielle Farina, and his advisor, Jacob Andreas, on what would become the consensus game. The core idea came from imagining a conversation between 2 people as a cooperative game, where success occurs when a listener understands what a speaker is trying to convey. In particular, the consensus game is designed to align the language model's 2 systems, the generator, which handles generative questions, and the discriminator, which handles discriminative ones. After a few months of stops and starts, the team built this principle up into a full game. First, the generator receives a question. It can come from a human or from a pre-existing list. For example, where was Barack Obama born? The generator then gets some candidate responses, let's say Honolulu, Chicago, and Nairobi. Again, these options can come from a human, a list, or a search carried out by the language model itself. But before answering, the generator is also told whether it should answer the question correctly or incorrectly, depending on the results of a fair coin toss. If it's heads, then the machine attempts to answer correctly. The generator sends the original question, along with its chosen response, to the discriminator. If the discriminator determines that the generator intentionally sent the correct response, they each get 1 point as a kind of incentive. If the coin lands on tails, the generator sends what it thinks is the wrong answer. If the discriminator decides it was deliberately given the wrong response, they both get a point again. The idea here is to incentivize agreement. It's like teaching a dog a trick, Jacob explained. You give them a treat when they do the right thing. The generator and discriminator also each start with some initial beliefs. These take the form of a probability distribution related to the different choices. For example, the generator may believe, based on the information it has gleaned from the internet, that there's an 80% chance Obama was born in Honolulu, a 10% chance he was born in Chicago, a 5% chance of Nairobi, and a 5% chance of other places. The discriminator may start off with a different distribution. While the two players are still rewarded for reaching agreement, they also get docked points for deviating too far from their original convictions. That arrangement encourages the players to incorporate their knowledge of the world, again drawn from the internet, into their responses, which should make the model more accurate. Without something like this, they might agree on a totally wrong answer like Delhi, but still rack up points.